Hello students, welcome back. Let us take a look at question number 8 of exercise 14.3, chapter 14, statistics. So it states that a random survey of the number of children of various age groups playing in a park is given below. We need to draw a histogram to represent this data. So we have the age, the class intervals of the age groups, so from 1 to 2 years, 2 to 3 years, and their corresponding frequency. Now we need to draw a histogram using this data. So what two things do we need to know, need to have when we need to draw a histogram? One, that the class intervals should be continuous. So we can see that the class intervals are continuous because 1 to 2, 2 to 3, 3 to 5, 5 to 7, 7 to 10, 10 to 15, 15 to 17. So there is a continuity, there is no discontinuity whatsoever. And the second and very important thing is that we need to know whether the frequencies that we are getting or the class intervals that we are getting, are they uniform, that is the class size is uniform throughout the classes given. So if you notice here, the class size is 2 minus 1 which is 1, here it is 3 minus 2 which is 1, whereas here it is 5 minus 3 which is 2, then 7 minus 5 which is 2, then 10 minus 7 which is 3, 15 minus 10 which is 5, and 17 minus 5 which is 2. So there is no uniformity in the class size. Now in these cases we need to adjust the frequency. So why do we need to adjust the frequency? Revising again, when we draw the histogram, if the bars are, first of all, the bars that we draw in the histogram, their areas are proportional to the frequency. So areas are proportional to the frequency, correct? Now bars are nothing but rectangles, so length into width is proportional to the frequency. So if this is constant throughout, that is the width is uniform throughout, let's say the class size was 2, this becomes a constant, so then the length, this is a constant out here, so we can just get rid of it, then the length becomes proportional to the frequency, that's the length of the bars becomes proportional to the frequency. But when the width is not uniform, we need to adjust the length. This needs to be adjusted, the lengths need to be adjusted such that the area becomes proportional to the frequency. So now what we are going to do is that we are going to adjust the length of the rectangles by adjusting the frequency. So we are going to use the formula of adjusted frequency, which is nothing but class size, smallest class size divided by class size. So I am just writing CS for class size of current class into frequency. So F for frequency, I am just writing FR. So what would that be for these class intervals now? Now if you notice, the smallest class size is 1, 2 minus 1, 1, 3 minus 2, 1. So that is the smallest class size. So we are going to take that 2 minus 1 upon class size of the current class is going to be again 2 minus 1 into frequency, which is 5. So this is going to be equal to 1 upon 1 into 5, which is equal to 5. Similarly, this is going to be 2 minus 1 upon 3 minus 2 into 3. So why 2 minus 1? Because 2 minus 1 is the length of the smallest class, or the class size of the smallest class size that we have, divided by the class size of the current class into the frequency, which is 3. So again this is going to be 1 upon 1 into 3, which is equal to 3, right? Now this is going to be 2 minus 1 upon 5 minus 3 into 6, okay, upon 5 minus 3 into 6. So this is going to be 1 upon 2 into 6, that is nothing but 6 upon 2. So 2 1s are 2, 2 3s are 6. So this is going to be equal to 3. I am just circling these numbers because we will be plotting these numbers for the histogram. So just for our convenience, I am I'm circling this. You could have written it in a pencil or a different colored pen. Alright. Then again this would be, so the numerator will remain unchanged, that is 2 minus 1. Only in the denominator we are going to take the class size. So this is going to be 7 minus 5 into 12. So this is going to be 1 upon 2 into 12, which is equal to 6. Then again 2 minus 1 upon 10 minus 7 into 9. So this is going to be 1 upon 3 into 9, which is equal to 3. Then again 2 minus 1 upon 15 minus 10 into 10. So this is going to be 1 upon 5 into 10, which is equal to 2. Then again we have 2 minus 1 upon 17 minus 15 into 4. So this is going to be 1 upon 2 into 4, which is going to be equal to 2. So you see how the frequencies, that is nothing but the length of the rectangles, are going to be adjusted, because the frequency is always plotted on the y-axis, right? These are the values. So the length of rectangle, if we wouldn't have found out these adjusted frequency, just see the difference: 5, 3, then 6 and half, 3, then 12 and 6, again there's a difference of half. Then I have 9 and 3, difference of 6, then 10 and 2. There is so much difference in 10 and 2, then 4 and 2. So now we have these frequencies on the y-axis and the class intervals on the x-axis. So let's get started. I'm going to take a difference of unit of 1 on both the axes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 and so on, and 18. Then again 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and so on. So I have my x-axis, y-axis and the coordinates. Now let's plot. So the first one is from 1 to 2 and the frequency is 5. So let's draw this 1 to 2 and 5. Then I have 2 to 3 is 3. So 2 to 3 is 3. Then I have 3 to 5 is 6. So 3 to 5 is 6. So 6 is here. I'm going to use a different colored chalk. Then I have 5 to 7 is 3. 5 to 7 is 6. Just my bad. 3 to 5. I have 1 to 2 is 5. Then 2 to 3 is 3. Then 3 to 5 is 3. So this is again 3. Then there is 5 to 7 is 6. So let's draw this. 5 to 7 is here and I had 6 here. And then there is 7 to 10, which is 3. So 7 to 10 is until here and a length of 3. So let me use a red color chalk itself. Then there is 10 to 15 and 10. So 10 to 15 and 10. So 10 is here. So what I'm going to do is I'm going to erase this scale over here. We will rewrite it later. I'm sorry, this is 10 to 15 and 2. So 10 to 15 and 2 will come here. What I did is I was making the mistake of taking this frequency as 10. We have not got to take this, we have to take this because this is the adjusted frequency. Then finally I have 15 to 17, which is 2. So 15 to 17, which is 2. So I'm going to use the same chalk because that's the rectangle of the same height. Or I'll use a different colored chalk because they are just next to each other. So we can differentiate. So this is the required histogram that we need, and I will rewrite the scale. 1 centimeter is equal to dash on y-axis. This is the histogram, but there is some labeling that is missing. So let's do the labeling. I have the frequency. So this is number of children on the y-axis, and on the x-axis I have age in years. So what is our scale going to be? Our scale will be 1 year on x-axis and 1 child on y-axis. So please take a look at the solution. Thank you for watching this video.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.